A water bond is indeed necessary, even if the majority of the house piping is plastic, with the exception of a copper header. The primary function of a water bond is to equalize the electrical potential between the water system and the electrical system within the building. This equalization is vital to prevent the buildup of static electricity and to mitigate the risk of electrical shock. Static electricity buildup can occur due to the flow of water through pipes, friction between dissimilar materials, and other factors. If a potential difference exists between the water system and the electrical system, a shock hazard is present. The water bond provides a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers. This is a critical safety measure. The size of the water bond is determined by the size of the service entrance conductors. In this scenario, the service entrance conductors are 4/0 aluminum. According to the National Electrical Code, typically referred to as the NEC, a number 2 copper water bond is required for this service size. It may seem counterintuitive to install a relatively large conductor for a small section of copper pipe, but the code mandates this size based on the service entrance conductors, not the length of the copper piping. Even though the copper header is only 10 feet in length, it must still be bonded to the water system. The copper header is connected to the water heater, pressure tank, and PX lines, all of which are part of the overall water distribution system. These components can become energized under fault conditions or contribute to static electricity buildup. Bonding the copper header ensures that it is at the same electrical potential as the rest of the grounded electrical system, minimizing the risk of shock. The NEC outlines specific requirements for grounding and bonding of water piping systems. The water piping system must be bonded to the service equipment enclosure, the grounded conductor of the service, the grounding electrode conductor, or to one or more grounding electrodes used. The bonding conductor must be sized in accordance with NEC Table 250.66, based on the size of the service entrance conductors. The point of connection of the bonding jumper to the water pipe must be accessible. The water pipe must be bonded within 5 feet of where the water pipe enters the building. If there is a water meter on the water pipe must be bonded on both sides of the water meter. The grounding electrode conductor serves as the main connection between the electrical system and the earth. The grounding electrode system often consists of a ground rod, ground plate, or the metal underground water pipe. The metal underground water pipe, if present and meeting certain requirements, can be used as a grounding electrode, but it must be supplemented by another electrode. The supplemental electrode can be a ground rod or ground plate. When using a metal underground water pipe as a grounding electrode, the interior metal water piping system must be bonded to the grounding electrode conductor. This ensures that the entire water piping system is at the same electrical potential as the grounding electrode system. Hex, a cross-linked polyethylene, is a non-conductive material. However, it is still necessary to bond the copper header to the water system because the copper header is connected to other conductive components in the system. These other conductive components can become energized under fault conditions or contribute to static electricity buildup. It is essential to understand that grounding and bonding are distinct but related concepts. Grounding provides a path for fault current to return to the source, while bonding ensures that all metallic parts within the electrical system are at the same electrical potential. Both grounding and bonding are critical for electrical safety. The NEC also specifies requirements for bonding other metal piping systems that may be present in the building, such as gas piping. These piping systems must be bonded to the grounding electrode system to minimize the risk of stray voltages and electrical shock. A common misconception is that plastic piping eliminates the need for water bonding. While plastic piping does not conduct electricity, it is still essential to bond any metallic components that are connected to the water system. These metallic components can become energized under fault conditions or contribute to static electricity buildup. Failure to properly ground and bond the water system can result in serious electrical hazards. These hazards can include electrical shock, equipment damage, and even fire. It is crucial to follow the NEC requirements for grounding and bonding to ensure the safety of the electrical system. The installation of the water bond should be performed by a qualified electrician. The electrician will ensure that the bonding conductor is properly sized, installed, and connected. The electrician will also verify that the grounding and bonding system meets the NEC requirements. The size of the grounding electrode conductor is determined by NEC Table 250.66. This table specifies the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. The grounding electrode conductor must be connected to the grounding electrode system. The grounding electrode system typically consists of a ground rod, ground plate, or the metal underground water pipe. The grounding electrode conductor must be connected to the grounding electrode system in a manner that provides a permanent and effective ground. A connection must be accessible for inspection and testing. The grounding electrode system must be tested to ensure that it provides a low impedance path to ground. The NEC requires that the grounding electrode system have a resistance to ground of 25 ohms or less. If the resistance to ground is greater than 25 ohms, the grounding electrode system must be improved by adding additional grounding electrodes or by other means. The purpose of grounding is to provide a low impedance path for fault current to return to the source. This allows the overcurrent protective devices, such as circuit breakers, to operate and clear the fault. Grounding also helps to minimize the voltage on metallic parts of the electrical system, reducing the risk of electrical shock. Bonding is the process of connecting all metallic parts of the electrical system together to create an electrically continuous path. This ensures that all metallic parts are at the same electrical potential. Bonding helps to minimize the voltage between metallic parts, reducing the risk of electrical shock. The NEC specifies requirements for bonding various metallic parts of the electrical system, including metal conduits, metal enclosures, and metal piping systems. The bonding conductors must be sized in accordance with NEC Table 250.102. This table specifies the minimum size of the bonding conductors based on the size of the circuit conductors. The bonding conductors must be installed in a manner that provides a permanent and effective bond. The connections must be accessible for inspection and testing. The NEC also specifies requirements for bonding equipment grounding conductors. Equipment grounding conductors are used to connect the non-current carrying metallic parts of equipment to the grounding system. This helps to minimize the voltage on the equipment and reduce the risk of electrical shock. The equipment grounding conductors must be sized in accordance with NEC Table 250.122. This table specifies the minimum size of the equipment grounding conductors based on the size of the overcurrent protective device. The equipment grounding conductors must be installed in a manner that provides a permanent and effective ground. The connections must be accessible for inspection and testing. It is important to note that the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to ensure the safety of the electrical system. For example, in areas with high soil resistivity, it may be necessary to install additional grounding electrodes to achieve a low impedance path to ground. In areas with sensitive electronic equipment, it may be necessary to install surge protection devices to protect the equipment from voltage transients. The proper grounding and bonding of the electrical system is essential for electrical safety. It is crucial to follow the NEC requirements for grounding and bonding to ensure the safety of the electrical system. If you have any questions about grounding and bonding, consult with a qualified electrician. The copper header is considered part of the metallic water piping system and therefore must be bonded. This is regardless of the presence of plastic piping elsewhere in the system. The grounding electrode conductor connection is typically made within 5 feet of where the water service enters the building and must be accessible. The bonding jumper from the service equipment to the water pipe must be sized according to the size of the service entrance conductors as specified in NEC Table 250.66. Therefore, even with plastic piping, the presence of the copper header mandates a water bond to ensure electrical safety and compliance with the NEC. It's crucial to remember that electrical codes are designed to minimize risks and ensure safety. Following them meticulously is of utmost importance.